look at another example on thing. I'm going to finish the example over there. And then we are going to do longitudinal shear. And it's the last section in shearing stress. Right. So on Wednesday, we did a problem like this. Okay. So next, so if you all look at your Wednesday notes, you'll see this. Next, we are going to find the maximum shear flow. And I'm aware that all of you are comfortable in taking the maximum shear flow from the top or the bottom of the centroid. You're more comfortable taking from the what? The bottom, am I right? Okay. But taking from the top, the answer will still be the what? Be the same. This is evident by looking at the what? First moment of area. So I want you to be comfortable with this. Okay, so we're going to finish off this example. So we are going to consider the bottom. Okay, so it's a continuation. Okay, so let me yeah, I'll do a copy for this page, and I'll come here. I'll do a paste. Okay, so this is on today's notes. So we are going to consider the bottom region of the centroid. Okay, so we will have Q about our z-axis. Okay, so this will be equal to QZ of the flange plus the QZ of both the what? Webs. Okay, so over here, the width is 7, the depth is 0.5, the Y bar, so 6.5 minus by 2.832, 2.8362 minus by 0.5 divided by 2. Okay, so this is for the flange, plus for the web, because we have left and right web, we have to consider. Now, before I do that, I missed something, which I apologize. We have to declare that is a box beam analysis. And we know that we have to use 2Q. Okay, so the left and right is the 2 over there. The depth, so the depth, you have to be careful, is 6.5. Oh, sorry, the width comes first. The width is 0.5. The depth will be 6.5 minus by 2.8362. 2.8362 minus by 0.5. So what we are talking about is this thickness over here, right? So we know the entire cross section, the entire height is 6.5 minus by 2.8362 minus by 0.5. And then the Y bar is the same thing. It's basically 6.5 minus by 2.8362 minus by 0.5, and the whole thing multiplied by half. Okay. So from here, we get what? Calculator. So 6.5 minus 2.8362 minus 0.5 divided by 2 times by 0.5 times by 7 is 11.9483. Sorry, that's my phone. I'm not going to answer it. 6.5 minus 2.8362 minus by 0.5 squared times by 0.5 times by 2 divided by 2. So this is about, I get 5. No. Hold on. 6.5 minus 2.8362 minus 0.5 squared times 0.5. Okay, so I get 5.0048. Did I do something wrong? Hold on, let me put this down first. 5.0048. So left and right 2. The width is 0.5 is correct. 6.5 minus 2.832 minus 0.5 correct. And I did the same thing and then divide by 2. Let me press my calculator again. 6.5 minus 2.8362 minus 0.5 divided by 2. Times by 0.5 times by 7 is equal to 11.9483. 6.5 minus 2.8362 minus 0.5 squared times by 2 times by 0.5 is equal to 6.5 minus 2.8362 minus 0.5 squared times by 0.5 times by 2 divided by 2 is 5.0048. So this will be equal to 11.9483 plus by 5.0048, right? So it's equal to 16.9531 inches cube. Okay. Then from here, I wonder, did I take my width wrongly? 6. Yeah, it's 7 multiplied by, oh, it's correct. I did multiply by 0.5. Okay. So this is taken from the bottom. So Q for point B or Q at the centroid is equal to 7 times 10 to the power of 3 multiplied by 16.9531, and then you divide by 92.569 and you divide by 2 because it's box beam. 7 power of 3 times 16.9531 times divide by 92.569 divided by 2, you get 640. Okay, you get 640.99 Newton or pounds per inch. Okay. Now, if we do it from the top, okay, so if we do it from the top, let me copy this diagram. Okay. So if we were to do it from the top, I'm just going to calculate the first moment of area. So we consider the top region. Now, the top region is a bit confusing, right? Part of it is a white flange. So this side of the structure was what? White flange. And then this is also at the what? White flange. Because we have 2 terminals. But at the center, it is what? Box beam, right? So which one do we use? Which one do we use? I don't know, right? I really don't know. So when you don't know, what do? You don't stare at me and I don't stare at you. You try. Are we clear? All right. The thing about any engineering course, you just have to try. Okay. If it does not work, it does not work. If it works, you learn something. So I don't know. I'm going to try. Okay. But before you try, you need to know the very, very absolute answer, what is correct. So we found that the correct answer is what? The Q should be what? 16.9531. If you take from the bottom, it has to be the what? Okay. Be clear. So try. Okay. So I'm going to try. I'm going to assume it to be what? Okay, I'm going to assume it's just a what? Box beam analysis. So for this case, we are going to have 2Q. Okay, so from the top, I'm going to put the Y bar is 2.8362. So the Y bar is equal to 2.8362 inches. Let me check again. Y bar 2.8362. Okay, so I'm going to try. Okay, so we are going to take the first moment of area at the flange. Okay, so QZ is equal to QZ at flange plus by QZ of the web. Okay, so as I said, we are considering the top region. Okay, width 2, 4, 11. All right, so 2 plus 2, 4, 4 plus 0.5, 0.5 is 5, 5 plus 6, 11. Width is 0.5. Y bar is equal to 2.8362 minus by 0.5 divided by what? By 2. Plus the web is twice. The width is 0.5. The depth is 2.8362 minus by 0.5 squared divided by, let's not, so I'll do it again. Multiply by 2.8362 minus by 0.5 multiplied by half. That's the Y bar. So this will be equal to 2.8362 minus 0.5 divided by 2 times by 0.5 times by 11 is equal to 14. Point what? 2241 plus 2.8362 minus 0.5 squared times